All right. So as mentioned, this session will focus on perspectives from engineering, design, a bit more focused on buildings, I believe. And we have three specific examples from 3 companies, projects, 2 from Switzerland and 1 from Norway. And then we will have a little bit of a summary of examples in the last session, in the last presentation. All right, to jump in, please welcome Michael from Switzerland. And tell us briefly who you are and what you do with VDC.
Thank you, Martin. I jump back one slide. Very warm welcome from my side, from Switzerland. My name is Michael de Martin, and I would like to actually connect what we heard, what is the future or where the road goes to in terms of automation, because we internally in my company, we automized some processes, some internal stuff in order to speed up our internal process. So my role is that I'm a HVAC engineer. I run a company with around 60 employees. And in this role, I'm never on the driver's seat. All the processes from all the projects are defined by someone else. So when I would like to have a VDC framework, I'm exposed to what either the client, the general contractor, or the architect has set up. The moment when we got hired, when we sign our contract, the project is already ongoing. So that gives a little bit a different perspective. And when I started here my program, my education in 2014, I went back home and I looked at our projects and I identified first internally, how can we speed up our processes and how can we use the model or what is available? Usually still a lot of projects using 2D drawings, and we try to speed up then internal engineering processes. So in Switzerland we have a very, very strong fragmented market. The average small-sized company has, Peter told us, 8 persons, meaning that our clients, which are mostly architects, have a very small company. So they don't have the knowledge of new processes. They just hand us out what they have and they start the process. That's reality. We run with my 60 employees, or we work on parallel-wise around 100 projects, and only 10 out of these 100 projects are really BIM projects. We have a lot of models, but at least half of the projects still uses 2D drawings, and then we do the models, we as HVAC consultants. So we try then to take what we have and to get more efficient processes. I would like to show you now how we did this. The example project I took here as a reference is a building what is mostly an office building, but also some labs are in there. And it's like an average project what we deal with in my company. And by using the BIM method as part of our internal process, we managed to speed up the efficiency in schematic design by 50%, meaning that it took us half the time to deal with the information. We have had a lot of other points. I will not read now point by point, but we also managed to really increase tender process. And you see there as well a number. It's again half the time we use for the same process. And we still got most of the time the same salary, meaning that as a businessman, I run the company, I have to make a good job with my company. That's really interesting. So how do we do that? we took a combination of our existing tools and added an automized process by taking out information either from a model or from 2D drawings. It doesn't matter what we receive, we try to automate the process, and that has been done by combining those tools. We automized the handover of information from one tool to the next in order to speed up the process and to eliminate typing mistake and hours by typing back-forward information. And it was a step-by-step development we did internally, and we always did small steps to prove them in real projects. And we combined the knowledge of a software engineer with the knowledge of the project managers. We set them on the same table, and they discussed how they can eliminate a lot of stupid work in order to speed up the process. And so we didn't, let's say, we didn't invested in a new software. We took what we have and we combined the software tools. This is a brief or a short overview. I'm pretty sure that each and every one of you uses some similar tools, but if you look at this landscape or this software zoo, this is what is in each and every project, and a little bit enhanced with other software given by the client or whatever. But within this software zoo, I would like to show you now what we are, for a project, are using and what we automized. We are not focusing on back office software or whatever. So for schematic design, we use the tools. There are example tools, but those are the tools, the main tools we use in my company. And we now have in the first phase to organize the data exchange. I'm only the HVAC guy, but we have so many projects where data exchange is absolutely not organized at all. We heard this in some presentations before. So we use Trimble Connect, and we buy the licenses and we hand them over to our partners. I'm pretty sure that you experience the same when someone would like to bring in an intelligent tool. Everybody says, oh, cool. But then always, when you start talking about the price of the tool, everybody says, oh, is it really worth? And we had to have so many boring discussions. So we said, we buy the tool and we hand it over to all our partners. And so then when we in schematic design have in a normal project this situation, all the different ways of exchange information, we use not only the Trimble Connect platform as a common data environment, but also Teams for communication and so on. But the goal is not to interfere with other tools or whatever. The goal is for us to make sure that our internal processes are running properly. So then, when you look at what happens when we eliminate this process, we connect this common data environment with our internal data tools. And so we can, on one hand side, fully automated exchange information. On push of a button, we export from every project in every data format our internal used models to everybody. And this, in a normal project, before we had this solution, took hours, when not days, just to store from IFC to DXF to PDF to whatever, back and forward, each and every cycle you go through with the project. You do the same stupid work again, and this is now fully automized, and we save not only hours, but also the brain of the people, because this is a really, really stupid thing what we still have, because I told you we have 100 projects parallel-wise, and we have at least 50 different formats from 50 different architects, and this has all been translated back and forward. So that's one side. Then in schematic design, we also use Excel, which we have had in all our projects before, and combine it with Trimble MEP, which is software tools we use for modeling. And what we do here, we take as an input all the information out of the model and feed it into Excel, do in Excel all our calculation in schematic design very roughly, but this takes then minutes to extract the information from the model into Excel, and then automized, we feed it back again from Excel into the drawings, into the models, and just with the push of the button, we go back and forward with this information. As soon as we receive a new model, we extract again the information, see what the delta is in Excel, run the calculation again, and have all the drawings, all the information back in the model without any typing back and forward. And this is, again, a very, very helpful situation, because in a standard process without automated tools, you just write back and forward information from one tool to the next. And yeah, again here, this saves not only man hours, it saves also, it gives the people who work in this process a lot of more information, a lot of more motivation, because they have more and quicker available information. So then when we go to design development, here we have a similar system, but we go more into details. Here now, from this building, that's the model what I used to run the calculations. This is now our internal model, the usual or standard MEP model. But when we then go from the rough model to the detailed model, when we do the calculations and the dimensioning and the sizing work, we again extract information out of the model, bring it into the Excel spreadsheet we used for years now. There we do the dimensioning, and then we write the information, what the different components need to have, back into the model. That's not rocket science, but when you have a large building with thousands of components, this work needs hours and hours, and when you combine the tools, when you automate the process, this is way faster than it was before, and it still combines the advantages of the different tools. So again, here from Nova to Excel and back into Nova. Push on the bottom. What then is the next phase is the tender phase, and there we use a different tool. You see it's the AAA tool. Down here, it's an old tool, I think Europe or Switzerland uses it. But again, here now, because we have the information flow from the model directly connected to this tool, we produce tender documents by pushing a button, and all the tender documents are ready. And this is in Switzerland pretty unique. I know one or two other companies who have the same system or the same way of producing the tender documents. All the others, they type again information from the model. First, they extract it into Excel sheets, and then they type it into the tender software tool they have. We automated this workflow and are able now to directly send out the information to the contractors. There is one discipline in Switzerland, the sanitary guys. They already can run fully automated price calculations based on the software information or based on the tender document information we hand them over. So this goes back and forth again without any human interaction, and the calculation then is handed back to us. What we also use in the tender phase, we connect or we hand over the model, the Trimble Connect model here, to the contractors as additional information, and they are then able to use all the different gadgets we have, VR, AR, or whatever, just to show them the complexity of the project, to show them how everything is arranged in 3 dimensions, that they can take in account when they do the pricing for the MEP stuff. So, as a summary, what have we achieved? We did a lot of very small steps, but with these small steps, we speeded up our process really, really in a good way. And this motivates the people, this gives us time to really do the design and not time demanding typing of information. And we combined the opportunities and all the advantages of our existing tools by putting them together. The challenges are pretty obvious. Each and every software tool has upgrades, has patches to fix or whatever, and we then always have to double check if everything works accordingly when there is an upgrade of software tool A, B, or C. And the more important thing is the human factor. We have to invest a lot in educating our people, but as soon as they have worked one time with those tools, they will never go back to the old-fashioned way in, again, using hours for stupid work. The outlook is that we try now becoming more intelligent models, because a lot of models we receive right now are really, really basic models. And the more intelligent the models come in, the less we have to work with them, the faster our process works. And as I said, in Switzerland, most of our projects is this, our internal projects. We would like to be in a VDC environment, in a VDC context with the whole team. But again, here it takes hours or years until each and every project works the same. So with this process we set up for our internal use, we are able to react and act much faster than all the competitors on the market. That was it. Thanks for your time.